Our objective in this lesson is to solve problems involving sampling distribution of the sample mean. Let's have a quick review of our previous lesson. Stop or go. Draw a green circle if the statement is correct and red circle if the statement is false. Number 1. If n is sufficiently large and drawn from a population with mean mu and standard deviation sigma, the sampling distribution of the sample means approaches normal distribution. This is go. Number 2. Given a random variable x with a mean mu and a variance sigma squared, then, regardless of the population distribution of random variable x, the shape of the distribution of the sample means taken from the population will approach normality. This is a go. Number 3. Central limit theorem tells us that if the sample is sufficiently large, the distribution of the sample means will be normal, regardless of the shape of the population. This is go. Last one. Central limit theorem gives approximation of the distribution of the sample means. This one is a stop. Do you still remember this formula? We use this to convert individual raw score to a standard score. How about this? This is the standard deviation of the sample mean. Now, what if instead of individual raw score, we are given sample mean? What formula are we going to use to convert it to standard score? We are also going to use this formula, but we are going to replace this individual raw score with sample mean, x bar. Now, since we are talking of sample mean, then instead of population is standard deviation, we're going to use the sample mean is standard deviation. So, instead of sigma, we're going to replace it with sigma divided by square root of n. We use this formula to convert sample mean to standard score. Now, sometimes the population mean is unavailable. So, instead, we may use the mean of the sampling distribution of the sample means because we have proven last time that the mean of the sampling distribution of the sample means is equal to the population mean. What if the population is standard deviation is also not available? If that is the case, we may replace the population standard deviation with sample standard deviation. But take note that this formula can only be used if our n is greater than or equal to 30. Another question now arises. What if our n is less than 30? Then that would be our next lesson. Next, remember me, this time with an exclamation point. When do we use z distribution or normal distribution? We use z distribution or normal distribution if the distribution is, of course, normal. And we know the population is standard deviation. That is why it is called normal distribution. We use it when the distribution is normal. Now, how do you know that the distribution is normal? It is usually written in a problem. You will see there, assume that the distribution is normal or something like that. Now, what if there is nothing written that the distribution is normal? Then you look for the sample size. If the sample size is greater than or equal to 30, then you may still use z or normal distribution. Why? Because the central limit theorem states that when the sample is sufficiently large, and what we mean by sufficiently large? n is greater than or equal to 30. The distribution approaches normality. That is why, even if the distribution is not normal, but when your sample size is greater than or equal to 30, you still use z or normal distribution. Now, what if my sample size is greater than or equal to 30, but the population standard deviation is not available? Like what I've said earlier, you may use sample standard deviation instead. You may also use z-distribution even though your sample size is less than 30 for as long as the distribution is normal and the population standard deviation is known. Let us start. The average IQ score is 100 with a standard deviation of 15. I have 4 questions here. We're going to discuss this one by one. Letter A, what is the probability that your IQ score is above 120? So the first thing that we have to do is to identify the given. We have here the average IQ score. So this is the population mean. Mu is equal to 100. Standard deviation of 15 referring to the population. So this is population standard deviation. Sigma is equal to 15. And then we have here IQ score is above 120. This 120 here is the variable x. Now, since this is referring to an individual raw score, your IQ score, then we are going to use this formula. Let us substitute 120 for x, 100 for mu, and 15 for sigma. And this will give us 1.33. I know you already know the drill. Next step is to create the normal curve. Let us locate 1.33. This is positive 1, and then somewhere here, that is 1.33. Let us analyze. We're looking for above 120. So this means above 1.33. Here is 1.33. Above means going to the right. So we are looking for this area. Now, let us recall our Z table. Let us look for the first 2 digits in this column, that is 1.3. And then the hundredths digit on the top row, here it is. Let us get the intersection. And the intersection is 0.4082. This area is from the mean up to 1.33. But we are not after this area. We are looking for this area. So how are we going to solve this area? We know that half of a normal curve is 0.5. So to solve for this area, we simply have to subtract this from 0.5. And this will give us 0.0918. This 0.0918 is the area we are looking for. Converting this into percentage, let us move our decimal point 2 places to the right. 1, 2. 9.18%. Now, let us answer the question. The probability that you have an IQ above 120 is 9.18%. Letter B, suppose 50 students were chosen randomly. What is the probability that their mean IQ score is below 95? The difference of this problem from letter A, here we already have a sample. And this 95 here is the mean of our sample. So this time, instead of individual raw score, we are given sample mean. So once again, average IQ, mu is equal to 100. Standard deviation, sigma, is equal to 15. We have a sample of 50 students, so n is equal to 50. And this mean refers to the sample, so sample mean of 95. Since we are given sample mean, the formula that we are going to use this time is this one. Let us substitute 95 for the sample mean, 100 for mu, 15 for sigma, and 50 for n. Others are having a hard time entering this in a calculator, so let me show you. Just make sure that your numerator is one group and your denominator is another group. So open parenthesis, 95 minus 100, that is your numerator, close parenthesis, and then divided by, so you have division here. Open parenthesis again, 15 divided by is square root of 50. And then close parenthesis. So this group is for your denominator, and this will be your answer. Other calculators are capable of entering in this manner. So this will be the answer. To have the decimal form of this, simply press this one. So rounding off to the nearest hundredths, this will be negative 2.36. Now, let us sketch the normal curve. Let us locate negative 2.36, negative 1, negative 2, then somewhere here is negative 2.36. Let us analyze. We are looking for below 95. So below negative 2.36. If it is below, then that is going to the left. Let us recall our z-table. Let us look for the first two digits on this column. Again, we do not have negative values here. So instead, we are going to look for positive 2.3. And then the hundredths digit on the top row. So we have here 0.06. Let us get the intersection. And this is 0.4909. This area is from the mean up to negative 2.36. But again, we are not looking for this area. We're looking for this. So to solve for this, we know that half of a normal curve is 0.5. So to compute for this area, 0.5 minus 0.4909. And this will give us 0.0091. I cannot write this anymore here. It's too little. So I'll just move the decimal point 2 places to the right, 1, 2, and this is 0.91%. Let us now answer the question. The probability that 50 randomly selected students have a mean IQ score below 95 is 0.91%. Letter C, suppose 40 students were chosen randomly. What is the probability that their mean IQ score is above 105? So once again, our population mean is 100. Our population standard deviation is 15. This time, our sample is 40. This 105 here is the mean of the sample. So sample mean is equal to 105. Even though there is nothing written in the problem that the distribution is normal, but because our sample size is greater than 30, then we are going to use Z distribution. We are given sample mean, so the formula that we are going to use is this one. Let us substitute 105 for x bar, 100 for mu, 15 for sigma, and 40 for n. This will give us 2.11. Let us sketch our normal curve. Let us locate 2.11. This is positive 1, positive 2, then somewhere here is positive 2.11. Let us analyze above 105. So it means above 2.11. If it is above, going to the right. Let's have our table. A part of our table. Let us locate 2.1 in this column. It's here. And then the hundredths digit on the top row. It's here. Let us get the intersection. And this is 0.4826. This area is from the mean up to 2.11. To solve for this area, again, half of the normal curve is 0.5. So we'll subtract 0.4826 from 0.5. And this will give us 0.0174. Moving the decimal point 2 places to the right, 1.74%. To answer the question, the probability that 40 randomly selected students have a mean IQ score above 105 is 1.74%. Letter D. Suppose 30 students were chosen randomly. What is the probability that their mean IQ score is between 95 and 105? Once again, the population mean is 100. The standard deviation is 15. This time, our sample size, n, is equal to 30. We have two sample means here. The first one is 95 and the second one is 105. Let us solve for the corresponding z-values of our sample means. Let's have the first one. Let us substitute 95 here. And this will give us negative 1.83. This time, let us substitute our second sample mean in our formula. And this will give us positive 1.83. Let us sketch the normal curve. Let us locate our first z-value, negative 1.83. If this is negative 1 and this is negative 2, then somewhere here is negative 1.83. Our next z-value is positive 1.83. So positive 1, positive 2, then somewhere here is positive 1.83. Let us analyze between 95 and 105. So it means between negative 1.83 and positive 1.83. Let us have our z-table. Negative 1.83 is just the same as 1.83 because they are symmetrical. So let us look for 1.8 in our first column. Here it is. And then we have 3 on the top row, 0.03. Let us get the intersection. And this is 0.4664. This is the area from the mean up to 1.83. And since they are symmetrical, this is also the area from the mean up to negative 1.83. So to solve for the total area, we just have to add these two or get 1 and multiply it by 2. And this will give us 0.9328. Moving the decimal point 2 places to the right, 93.28%. Let us answer the question. The probability that 30 randomly selected students have a mean IQ between 95 and 105 is 93.28%. Let's have another one. The age of teachers in Bright Elementary School is normally distributed with a mean of 33 years and a standard deviation of 5 years. Find the probability that a random sample of 25 teachers will have an average age of greater than 35 years old. Our population here is the teachers in Bright Elementary School, and their mean age is 33. So this is our mu. A standard deviation of 5, so sigma is equal to 5. We have here sample of 25, so n is equal to 25. And the average age of this sample is 35. So this is the sample mean. Since we are given the sample mean, the formula that we are going to use is this one. Let us substitute 35 for x bar, 33 for mu, 5 for sigma, and 25 for n. And this will give us positive 2. Let us sketch the normal curve. Let us locate positive 2, 1, 2. Let us label it. Let us analyze greater than 35. So it means greater than 2. If it is greater than, then it is going to the right. Let's have our table. Let us look for 2. So this is 2.00. Here it is, 2.0. And the hundredths digit is also 0. Let us get the intersection, and this is 0.4772. This area is from the mean up to positive 2. But we are not after this area. We are looking for this area. To solve for this, we know that half of a bell curve is 0.5. So to solve for this area, we simply have to subtract 0.4772 from 0.5. And this will give us 0.0228. Moving the decimal point 2 places going to the right, 2.28%. Now, let us answer the question. The probability that 25 randomly selected teachers will have an average age greater than 35 is 2.28%. You might ask me, Ma'am, is it all right to use z-distribution if the sample size is less than 30? Yes, like what I've said earlier, if the distribution is normal and the population is standard deviation is given. For the summary, here are the two formulas that we use in this lesson. We use this formula if we are given individual raw score and we will convert it to standard score. If we are given sample mean, then we make use of this formula. Now, it is time to check your understanding. Pause this video for more time. Let us answer. A lending company said that the mean loan applied in their company is 120,000 pesos with a standard deviation of 50,000 pesos. If 35 debtors were randomly selected, what is the probability that they will apply for a mean loan amount of at least 100,000 pesos? So we have here 120,000. This is the population mean. A standard deviation of 50,000 pesos. So this is sigma. And then we have 35 debtors randomly selected. So n is equal to 35. And the mean of 100,000, which is referring to the sample. So sample mean of 100,000. We are going to make use of this formula. Let us substitute 100,000 for x bar, 120,000 for mu, 50,000 for sigma, and 35 for our n. And this will give us negative 2.37. Let us sketch the normal curve. Let us locate negative 2.37, negative 1, negative 2, then somewhere here is negative 2.37. Let us analyze at least 100,000. So at least negative 2.37, meaning the smallest value is negative 2.37. So this means going to the right. We know that half of a normal curve is 0.5, so we only have to look for this area. Let us have our z table. Let us locate negative 2.37. So instead, we're looking for positive 2.3. And then the hundredths digit, 7, is on the top row here. Let us locate the intersection. And this will give us 0.4911. This area is from the mean up to negative 2.37. To solve for the total area, we just have to add 0.4911 to 0.5. And this will give us 0.9911. Moving 2 places, going to the right, 1, 2. This is 99.11%. So the probability that 35 randomly selected debtors will apply for a mean loan amount of at least 100,000 is 99.11%. Gets? Our next lesson is t-distribution.